Ele teria um pé.
ट्रेन में पहुंच गए क्या? क्या हुआ, जीत गए क्या हार गए आगे? यार मेरे को कैसे बचना है?
आज लेट गए थे, कमीना मैम आ चुकी थी, मैं 9:05 को पहुंची
Andheri East. Right spot conveniently located at just 5 minutes walk.
उसको खत्म कर ले सामने
In our journey of over a decade, we have proudly trained over 2 lakh students.
पागल
We have also been Deloitte, Silicon India, and other accreditation bodies.
वो अगर वो दूसरी वाली रहती ना तो ऐसी नहीं रहती थी वो.
Never before, in our spacious and comfortable classroom, with high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point of the world. Hybrid mode is a game changer, as you can enjoy the benefits of a live classroom from the comfort of home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
So the collaboration with XLR was an excellent one. We conducted a Power BI workshop with advanced experts over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I'm sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer Mr. Karthik
ఆపరేషన్ చేయకపోతే ఊర్లో పోయి లోపల మీకు మన
very
తేడా
detailed
పడుతుందండి
manner on how to give great insight using very
ఆపరేషన్
complicated
చేయాల్సిందే
मेरा तो शौक ही रहना है.
అది ఇక్కడ కూడా ఈరోజు 3 levels of competition ఫస్ట్ లెవెల్ లో 5 స్టోరీస్ పోటీ వచ్చారు సెకండ్ లెవెల్ క్లాస్ వచ్చే కూడా ఫస్ట్ స్టార్ట్ కదవా ఫస్ట్ లెవెల్ స్టార్ట్
from the course, and it was a great experience attending the workshop. It was very helpful. We had an hands-on approach in this teaching, and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR like this.
టెన్త్ అయిపోయింది జాబ్ ఉన్నాడు ఆఫీస్ మేనేజర్
Good evening. I hope you are doing well. We'll start the session. Murli sir, good evening.
Yeah, very good evening.
Yeah, you can start the sessions.
Yeah. Hello, very good evening, students. So today's topic is about Kubernetes. So let me share my screen. So what is Kubernetes? What is Kubernetes? See, Kubernetes is an open source platform. So that helps us to manage, deploy, scale applications that running in the containers. So it's more probably like a Docker. So before Kubernetes, how it was, the developers had to manually start and manage each containers. So which became very much difficult as a number of application grew. So Kubernetes helps us to solve by automating the task like starting the containers, balancing the traffic as well, and restarting the failed applications. And also the scaling up and scaling down based on the demand. So what is Kubernetes? So Kubernetes is an open source. So open source platform. So it mainly helps in deploying automatic deployment, automatic deploy. So what is automatic deploy? So if I want to run the application with a copies of 3, so it will create 3 pods. So if I want to run the application of a copy of 3. So what does it does? So it creates a pods, creates a 3 pods. So each pod has a container. Each pod has a container. So, and it pulls the Docker image from Docker up and then schedules them on the available nodes. So what does it does? Pulls the Docker image from Docker up or registry. Then schedules. So schedules them on available nodes. So nodes means the pod running container. That is, we can put it as EC2 instances. So how it works? How? So we write the YAML file. For example, deploy main.yaml. So this is the structure, and we define the application name, and we define the image name, and we define the replicas, and we define the pods. So if we run the application, the kube scheduler will deploy the nodes. So let me discuss it later. So it will do automatic deployment. This is Next one is automatic manage. So how it will manage? So whether the containers are healthy, whether they are responding, whether they are restarted or started. Like if we update the application, so if there is a downtime, automatic manage. So so it keeps checking the containers are healthy or not. So if not, it will restart. If not, it will restart. So next is automatic scaling. So for example, so if your website suddenly gets like, for example, 1,000 users, so Kubernetes will increase the number of pods. For example, if you get request of 1,000 users request, so what Kubernetes will do, it will increases the pod, increases the pod. So it also balances the traffic. So it also balances the traffic. And it will monitor the container, the last. Monitor the container. So how it will monitor? Like it has integrated tools like Prometheus for metrics. We use for metrics Prometheus, like the CPU usage metrics, memory utilization metrics, and we have a Grafana dashboard to visualize the metrics. We have a dashboard. And we have different tools like ELK stack for logs. So how it will monitor? So it will monitors the pod health and will checks the node resource utilizes usage. And it will monitors based on the request counts. So how Kubernetes helps us to automatic deploy and manage the containers and automatic scales and monitors the containers. So think like Kubernetes as a brain of your application. So it keeps everything running smoothly. So even if the app crashes or grows or changes. So it was originally built by Google. So now it is managed by CNCF. Now managed by CNCF. What is CNCF? It's a cloud native computing foundation. Cloud native computing foundation. Originally built by Google. So next we'll discuss about why we need Kubernetes. So why we need Kubernetes. So like just imagine like you are running a web application like using a Docker. So Docker helps us to put your application inside the container and run them. But what happens when you want to run like 50 containers? So if you need to run 50 containers. So if one container crashes, like you will restart. And also like if you want to update the application, one container crashes. So you will manually one update. And also like you want to update your application without the downtime. And also like you want to auto scale when there is high traffic. So you want to auto scale when there is still traffic. So before containers, like we used to do like this. So after Kubernetes, it automates all of this. So it has a auto healing mechanism. So like before Kubernetes, how was the old way? Before Kubernetes, so what was the previous method we used to do? So we used to do in a bare method, that is this servers or the VMs we used to deploy the application. So we used to run the application in directly on the server. So then came the virtual machine, so that we can isolate the application. So in this, like we need to manually set the OS application and networking. So we need to manually set up the OS softwares application networking. So then came the Docker. So what it does, so it simplified the packaging and running apps as a container. Simplified the packaging and running apps as a container. Running apps as a container. But what is the disadvantages in Docker? So Docker cannot manage the multiple containers. So that's where the Kubernetes came. So with the help of Kubernetes, like how do you describe the application? So in the YAML file, we will describe the application. So we'll define what to run, how to run, and how many replicas should be there, and how to expose the application to the end user. So it automates the deployment and manages it itself. It's like if any application crashes, it restarts. Self-heal. If any application crashes, so it restarts automatically without the downtime. So it supports rolling updates. It supports rolling updates. That means like with a zero downtime, we can update the application. Zero downtime. We can update the versions or softwares. So we can scale automatically up and down based on the demand. We can scale automatically up and down based on the demand and traffic spike. And also you can monitor and manage networking between the containers. You can monitor, manage the containers, manage the networks between the containers. So let's discuss the architecture of Kubernetes. So what is architecture? So we have a master node and the worker node. We have the master node and we have worker node. So we define as worker node 1 and here also worker node 2. So there are 4 components in the master node. First one is the API server. Second component is the scheduler. Third component is the controller manager. The fourth component is etcd. And in worker node, we have kubelet, we have container D, that is Docker, container engine, we have kubeproxy, and there will be running containers, that is pods, pod 1, so there will be kubectl, and there will be user kubectl, and there will be user interface. So inside the pod, there will be containers. So what does API server does? So it's like an entry point in Kubernetes. API server. So whatever the user enters the command, everything should go from the API server, and it's like an wire in entire communication. So it's like an entry point. So whatever the command it is passed, it should go through the API server itself. So whatever the commands should travel to the API server. So what is scheduler? So decides where the pod should run, in which pod the container should run. So this decides on which pod the container should run. So it checks which pod is healthy, then it runs the container. Scheduler. So it decides where the container should run on which pod the container should run. And the next component is controller manager. So what does this component does means, so it will keep checking the desired state with the actual state or the current state. So if we mention there should be 5 pods running, so it will check if there is 5 pods running. So it means, so if any pods is crashed, or it will update to the API server and the scheduler, and the scheduler will run the pod, restart the pod, or start the new pod. So it keeps checking desired statements, like whatever we give the input in the YAML file, it checks with the current state. With current state. So what is etcd? So it's a key value database, collects to store the values of the cluster data. So key value database for storing cluster data. So what does API servers does means, like whatever the commands from the kubectl, to create a pod, to run a container, to create a namespace. So it should go from the API server to the worker node, from the master node to the worker node. So master node is like a manager. The worker node will do the work. So scheduler means it will schedules the job. So it checks the pod, which pod is empty, and then run the container in that pod. So coming to the controller manager, so it keeps checking the desired state with the current state. So whatever we defined in the YAML file, let's say like we define like we want to run like 5 pods. So it will check if there is a 5 pods running or not. If there is not running, it will start the running. So next comes with the etcd. It's a key value data store for storing the cluster data. So let's come to the components of worker node. We have kubelet. So what does kubelet does? So it will talk to the master node, then runs on the container. So it receives the feedback. It receives the signal from the master node. It receives the job from the master node and does the job by running the container on the worker node. So it talks to master node and receives the signal and runs the container to the node. The second component is container engine. So we have container engine like Docker, and container T also is a container engine like a Docker. So we need a daemon to run a service. Container engine. So runs the container like Docker. We have also we have container D. It's like Docker. The third component is kubeproxy. So what does kubeproxy does? Like it exposes an application to the end user, or it manages the network between the containers, and it helps us to discover the node, manages the network, and also service discovery, call it as. In the node. So what are the components of worker node? We have kubelet, container engine, and kubeproxy. So what does kubelet does? Like it will communicate with the master node. So then make sure like it will run the container in the pod. So its main action is to execute the job, kubelet. So what is kubeproxy? So it handles networking communication. like it exposes an application inside or outside of the cluster. So what is pod actually? So pod is the smallest and simplest unit in Kubernetes. So what does it represent? Like it's like a smallest instance of an application. So each pod made up of a container. So pod is the simplest unit in Kubernetes. So what is pod like? Pod is the simplest unit in Kubernetes model. So what does it represent? So it represents a single instance of an application. Single instance of an application. So it's like running a container, single unit of container. Okay, let's discuss about what is the workflow of the Kubernetes. So what is the workflow of Kubernetes? So firstly, we define the application configuration and then deploy the application. Then the Kubernetes API server will take off and the control manager. So we define the application configuration. So how do we define? So we're adding the YAML file. We have YAML file, we have JSON file. So what does it contains? YAML file. So it contains the specification of the containers, specification of the pods, specification of the services and other resources. Specification of pods, containers, and services and other resources. So then we have deploying the application. So after configuring the YAML file, then we're going to deploy the application. Deploy the application. So how do we deploy the application? So we use kubectl command. So it's like a command line tool. kubectl. So it's a command line tool. To interact with the cluster. So in this, like Kubernetes will take care of scheduling the containers, scheduling the containers, and also creating the pod, creating the pods and managing the resources. So then comes the API server. So API server will receive the request and then from receive the request and configuration from the users as well. So after receiving the request, it validates and process this request. So it will receive the request from the users, then validates the request. So then there is a controller manager. So what the controller manager will manage means, so it will manage the replication, the nodes. So it will check the desired state with the current state. Checks desired state with current state. So it will manage tasks like deployment, replication, replica set, namespace. So then comes the etcd. So we call it as a distributed key value store. So it stores the configuration data and the state of entire Kubernetes cluster. Distributed key value store. So what does it store? It stores the configuration data. It stores the configuration data. So also the state of the cluster. State of the cluster. So next comes with a scheduler. So what does scheduler does? So scheduler is responsible for assigning the pods so to the worker node. So it is responsible for assigning the pods to the worker node. So then comes with the kubelet. So then comes with a kubelet. So what does actually kubelet means? So it's like an agent running on each node. It's like an agent running on each node of the cluster. So let's discuss like what are the top use cases of Kubernetes? Top use cases of Kubernetes. So we use mainly in the container orchestration. So why we use like it provides a like unified platform for deploying, managing, and scaling containerized application. So container orchestration. So the second use case is microservice architecture. Microservice architecture. So it enables the deployment of microservice as a container. So it also manages the life cycle and it will facilitate the communication between different services. So the third use case is application scaling. So how it will useful means, so it helps us to automatically scale horizontally. So by adding or removing the instances of the containers, like based on the demand. So fourth use cases is service discovery and load balancing. So how means like it automatically scales or assigns a stable IP address and also a DNS name to the services. So in the load balancing, it will distribute the traffic across service instances. The fifth use case is rolling updates and deployments. Rolling deployments or rollbacks. So it allows the application to update without the downtime. So how means it replaces the old instances with a new one. So it ensures like a smooth transition. So even for the rollbacks, it can be performed or reverted back to the previous version without the downtime. So these are the top five use cases. First one is container orchestration, and second is microservice architecture. The third one is application scaling. The fourth one is service discovery and load balancing. And the fifth one is rolling deployments and rollbacks. So do you have any questions? The chat is open. Yes, we will provide the notes at the end of the course. Yeah, let's take a break and come back at 8:15. So let's start. So we have to install Kubernetes, we have different approaches. So to install Kubernetes, we have many approaches. So to install in a local machine, we have a Minikube. So it is easy for setup in a single node cluster. We call it as a single node cluster. So we can install Minikube from the official website. So it is mainly used for local testing and the development. Local testing and development. So secondly, we have Docker desktop. So it has a built-in Kubernetes function, so which also supports Docker as well. So in the cloud managed services. Firstly, we have Google Kubernetes Engine, GKE, we call it as GKE, Google Kubernetes Engine. Google Kubernetes Engine. It is fully managed Kubernetes on the Google Cloud platform. So we can create the cluster in the Google Kubernetes console or the command line interface. Secondly, we have EKS. EKS. It's Amazon Elastic Kubernetes Services. Amazon's Elastic Kubernetes Services. Thirdly, we have AKS. It is Azure Kubernetes Services, by Microsoft. Azure Kubernetes Services. So let's start implementing. So we're going to set up the Kubernetes cluster in EKS. To set up the Kubernetes cluster in EKS. So why EKS means? So AWS manages the master node. So master node is managed by Amazon. Master node is managed by AWS provider. So what it manages? So it manages the necessary applications, installations, container runtime, master processes. So it also manages the scaling also and also backup. So that's why we focus on deploying the application rather than the infrastructure. So in this, like we need to create the worker node. So we need to manage the worker node. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . .
So let's start implementing.
So we need to launch an EC2 instance. Firstly, we need to launch an EC2 instance. So go back to the AWS console. So launch instance. So name it as EKS VM. Select Ubuntu. Instance type as t2.micro. Select the key pair. Select the security group. Hello SSH22 and launch instance. So from this instance, we're going to create the EKS cluster. So we can also create from the EKS console. So instead we are using instance because this is the easiest way, simplest way. So copy the public IP. SSH into the server. So username as Ubuntu. Add the private key. So first we're going to install kubectl. So to interact with the cluster. So we have a command. So it is downloading the kubectl file. It takes time. So then making the kubectl in the executable format. Then moving the kubectl to the bin folder. So checking the version, kubectl version -, short client. So 1.19. So next we're going to install the AWS CLI, command line interface. Sudo apt install unzip. So downloading the AWS CLI file, then unzipping the file. After unzipping, we're going to install AWS CLI. So checking the AWS version 2.27.46. So then installing EKS CLI, it's a tool. So then moving to the bin directory. EKS version. So before creating the cluster, we need to create an IAM role and attach to the EC2 instance. So go back to the console. So search for IAM role. Then go for roles. Create role. Select AWS services. Select services EC2. Next, select administration access. Next, so name the role as anything like EC2 access, EC2 EKS access, then create role. So after role is created, go back to the instance, click actions. So go to the security. So modify IAM role. So in this, select newly created EKS role. Next, update IAM role. Then start creating EKS cluster. So we have syntax, how to create an EKS cluster. So EKS create cluster hyphen name and the cluster name and hyphen region name and node type as an instance type. So node minimum 2, maximum 2, and which zone, availability zone you are going to create, like US 1A or 1B. So EKS create cluster, I'm giving name as test cluster, and the region is US 1 North Virginia, and the node type is T2.micro, and the zone I have selected is US East 1A and 1B. So press enter. So it will start creating. So it will take like 5 minutes time. So you can go back to the cluster. So it's creating test cluster. So how to search? Search here as EKS. So here is Elastic Kubernetes Services. So EKS is chargeable. So the moment you created the cluster, so it is chargeable. So after creating the cluster, don't forget to delete the cluster. You can see the test cluster is active, but still it is creating the cluster. So go to the test cluster. Till node is getting created. Okay, the EKS cluster is finally ready. There is an US East one. So refresh the console once. So you can see the node group. So there will be two nodes up and running here. Test cluster node group and test cluster node group. So we have set like T2.micro. So one is it is installed in 1A availability zone US East 1A and another is US East 1B. So it has taken EKS cluster security group default. So to check the nodes QCTL get nodes. So you can see these are the worker nodes. And this is the master node. So this is managed by the AWS cloud provider, this master node. So you can also check kubectl get pods because there will be no pods running, no resource found in default namespace because no container is running. So done with the cluster setup. So do you have any questions? So please ask any questions, any doubts regarding the cluster setup, Kubernetes concept. Master node is managed by the AWS cloud provider. So the worker node is managed by the user usage. So we can define the limit, the maximum nodes it can have like 10 and minimum like 2 nodes to be up and running. Yeah, in AWS it takes longer time, like it takes around 15 minutes. In GCP it takes hardly like 2 or 3 minutes because it was developed by the Google in the earlier. Yes, like EC2 instances are created automatically. So where we define EKS, create cluster, we define the nodes. So we can also set the Kubernetes in Windows PC as well as a local machine. So using the Docker desktop application, so we need to enable the service in the Windows machine. In the application as well, we need to enable the feature of Kubernetes. So that's how we can test the application. We can do some projects and okay. So there is some question. Show me one small application running while Kubernetes. So we need to explain in tomorrow's class. We're going to explain what is pod, what is namespace, and how to run a container in Kubernetes. So we will do tomorrow. So any questions regarding Kubernetes? So don't forget to delete the cluster, whichever you have created now. So the application only runs in worker node only, so not in the master node. So master node is like it's like a brain of the cluster. Like it decides where the container should run and when the container should run, and also it manages the cluster state, like auto scaling and ensure like everything is healthy. See, for basic infrastructure, we can have one master node. For high availability and redundancy, we should have two or three master nodes. So there should be one backup master node, we call it as. So what happens is developer gets deleted any parts by means like how will get take over by Kubernetes. Like see, Kubernetes will automatically create a new pod. So whatever the developer deletes. So any questions? That's it. Okay, let's wind up the session for today and we'll continue for tomorrow for namespaces.
Thank you,
Okay,
sir.
thank you.
So, yeah, we will wind up for the day. We will meet again by tomorrow at 7. Yeah, so dear students, thank you all. Thank you for joining. So we are winding up. I'm just sharing once again the attendance link on the chat. If you have not marked the attendance, kindly mark your attendance. I'm just giving a reminder. Okay. Thank you all. Have a great day. Thank you for joining.